So let me copy this. We'll just count first of all the number of words in this. So for this total number of words in the file, it's actually the correct word would be words.count. So anyway, so I will just use this flatMap lines.count. Okay, or I will just rather use F6. These are actually all the words. Okay, because we are normally like breaking all this like text into individual words. So words is a better name here. Okay, so we have now total number of words in file. We had to call this words.count. It will give me all those words. And now let's print out few words from start. So I will just use sout first few words so that our understanding is correct, that it's actually breaking down this text. For example, I expect that it should give me the text of like these type of words as my initial words. Let's print it out and see whether it's correct or not. So what I will do is that I will use words.take method here. So take, it will just take the first say 10 elements, 10 words, and then for each it will print. This is called for each, and I will just use this as out. Okay, and that's it. It should print all the words. Alt L. So guys, I have also used this map lines, and I have printed out the total number of lines in this file using map lines.count method. Now let's revise first that what we have done so far. So we have got this Spark conf here, which we created using our local star, which is that all the cores in my laptop would be, there are 4 cores, so all cores would be used for the RDD creation. And now we created this Spark context by calling this constructor and passing this Spark conf object. This is what we have been doing in the previous unit test as well. And now we are our task is to read this magnacard.txt file, which we have stored in a ZZ format in our resources folder. And this looks like this. And our task is to count each number of words here. So first of all, we actually call this text file, which will create a Java RDD of lines of each string, and each line would be stored here in this as in a Java RDD format using this. And when we do this count, it will give me the total number of lines present in that file. Again, now we first of all we tried using the map approach. So by map, when we call this line.split based on the space, so it will create an array of string, and then we wrap it into a list. So this whole expression will actually result in giving a list of a string for each line in that RDD. And then when you use a map, because for map we are mapping it from line to a list of strings. So this is actually returning me an RDD of list of string. And we expect that again that map lines.count should be exactly same at lines.count. So I can also do an assert here, assert equals. So this lines.count should be same. Lines.count and map lines.count. Okay. Alt enter. Yes. Because this is nothing more than we are already getting this lines in text file. So our map is giving the same thing. It's giving me a list of string. But we don't want this. We want all the words individually here. So that's why we have to use flatMap. So again, we again pass this expression here. This expression is actually doing the same thing. It is creating, for each line, it's creating a list of string. But because flatMap, it requires an iterable. That's why we have to call an iterator on that. And then this satisfies this flatMap. And then flatMap will just flatten the whole stream into string. So now it means that this verse is containing all the words present in our file. And then we actually print the words.count by counting the total number of words in the file. And then we print first few words. We print using the take method. We print the first 10 words using this for each system.println. So this was all about this test case. Now let's run it and see our expectation is correct. I'll run this. It's running now. It takes some time, a little bit to initialize it because we are dealing with Spark context and like big data. So, okay. So our test case is run now and our asset is also same as expected that. So first total, let's go on line by line that what's going on. So first of all, we created this text file and we got this Java RDD of string for each line and the count is same. So the total number of lines in this file is 1453. Similarly, for mapped lines as well, it is not doing anything special than this lines. That's why the lines count is still same. So it's again 1453 as expected, and our asset is good. Now we want each of the individual words here. So this for which we used flatMap, and flatMap is giving me total number of words in the file, which is 14629. And once we print first few words, we're printing like 10 words, right? So this is why what it's printed. So let's compare this to the text of Magna Carta. So this is what we already see, the text of Magna Carta. And there's a space there. The space is also taken, the whole line. And then John by the grace. So 5, 6, and total 10 number of words. So we can also like do, so 1, 2, 3, 4, 5, then the blank line here, and then 5, 6, 6, 7, 8, 9, 10. Yeah. That's why it has printed these as well. John by the grace. Okay, so this is what we expect, that it has converted everything into like blank. We can also write some more methods to actually trim, for example, this line. We can specify it by using this regex here. This all can be done. But the idea here is that the flat map is the ideal to flattening a list of string or something, for example, in this example, and meeting our use case to break it into individual words. So guys, this was all about the flat map function, which is a narrow transformation. In the next video, we'll see transformation with filter. So map, filter, and reduce. These are the basics of functional programming. And this is why the Stream API in Java was also designed. So in the next video, we'll look more into the filter function. So see you all in the next video.